Hello friends, welcome to our channel RF Design Basics. Today in this lecture we are going to study about Boolean functions and their representation. We can represent the Boolean function in two forms. First is sum of product and second is product of sum. We know for any digital logic circuit there are some inputs and there are output. So suppose inputs are x, y, z. So these x, y, z's are called input variable, and this output can be represented as Boolean function of this input variable. So f of x, y, z. So this is Boolean function of the logic circuit. Now we will see how to represent this Boolean function as sum of product and product of sum form. First we will see sum of product, that is SOP. What is SOP? As the name suggests, SOP, sum of product. That means we are adding the product terms. Suppose we have a function given as f of ABC as a bar b plus bc bar. So what is this term? This is product term. This is also product term. And we are adding two product terms. So this form is SOP form. Sum of product. Sum of product. This is called product term. In POS form, POS means product of sum. Suppose a function is given as ABC, f of ABC equals to a plus b bar multiplied by a bar plus c. So these two are sum terms and we are multiplying the sum terms. So this form is called product of sum terms. Product of sum form. This is POS form. And these terms are called sum terms. We saw SOP and POS, normal SOP and POS. Now we will study about a standard SOP and standard POS. So a standard SOP, standard sum of product, is also called canonical SOP form. We know SOP means adding the product terms. Here in standard sum of product, the product terms are called minterms. Suppose we have a function of xyz given as xyz plus x bar yz plus xy bar z. So these terms will be minterms. These are product terms. These product terms are also called as minterms for SSOP. And these minterms will contain all the variables. Here variables are x, y, z. So it will contain all the variables either in normal form or in complemented form. So these three are minterms here. And we are adding this minterms. So SSOP form is summation of minterms. If there are n number of input variables, then number of minterms will be 2 to the power n. Suppose we have two variables a and b. Write it here, a and b. We will write the possible minterms for a and b variable. We know a and b will take 0 and 1 as input, 0 and 1 values. So combination for 0 and 1 will be 0, 0, 0, 1, 1, 0 and 1, 1. We write 1 as the variable and 0 as complement of variable. 1 as variable and 0 as complement of variable. So we can write this as 0 is a bar, b is b bar. So a bar, b bar. This is a bar, B. In same way, this is A, B bar and AB. So these are the main terms possible for two variables A and B. We write it as M0, M1, M2, M3. Now let us take a function f of AB given as AB bar plus AB. So how we can write it? AB bar is M2 and AB is M3. So we can write it as summation of mean terms of 2 and 3. Summation of M2 and M3. Now let us see what is a standard product of sum, SPOS. We also call it canonical POS form. So we know the POS, product of sum, means multiplying the sum terms. Suppose we have a function given as f of x, y, z as x plus y bar plus z multiplied by x bar plus y plus z multiplied by x plus y plus z. So this is the expression in a standard POS form. Here these are sum terms, and these sum terms are also called max terms. This is also max term, this is also max term. These max terms contains all the variables. Here variables are x, y, z. So it will contain all the variables either in normal form or in complemented form. So here x is normal, y bar is complemented. If there are n number of variables, then the max terms will be, number of max terms will be 2 to the power n. Suppose we have two variables. So number of max terms should be 2 to the power 2 equals to 4. Suppose we have variables a and b. So combination for a and b can be 0, 0, 0, 1, 1, 0 and 1, 1. So how to write max terms for these combinations? We write 0 as variable and 1 as complement of variable. So 0 means here A, here B. So max term will be A plus B, because this is sum term. Max terms are sum terms. So here this will be A plus B. This is A plus B bar. B bar because 1. A bar plus B. And this is A bar plus B bar. Suppose we have a function given as f equals to a plus b bar and a bar plus b. Multiplication of these two sum terms. So this is in SPOS form, and this can also be written as product of, product is represented by pi, max terms of. This a plus b bar is second term. We can write it as m0, m1, m2, m3. So this is m1. A plus b bar is m1 and a bar plus b is m2. So we can write it as product of m of m1 and 2. We can also write this SOP and SPOS form expression from truth table of a digital logic design. Suppose we have a function f of xy and the truth table is given as x, y, f 0 0 0 1 1 0 1 1. So this is the output 0 1 1 0. So min terms for this will be M0, M1, M2 and M3, and max terms will be M0, M1, M2 and M3. So this function f of xy can be written in SOP form, that is standard sum of product form, as f of xy equals to summation of where the output is 1. This is the output 1. So for this, the min terms will be x bar y and xy bar. So these are m1 and m2, summation of m1 and 2. This is x bar y plus xy bar. From truth table we can see this is the truth table for XOR operation, and representation is x bar y plus xy bar. Similarly, in SPOS form, standard product of sum form, we can write it as f of xy equals to product is represented by pi max terms where output is 0. So for these two, output is 0. So M0 and M3, 0 and 3. This can be written as x plus y multiplied by x plus y multiplied by x bar plus y bar. For SOP, we consider the terms where output is 1, and for SPOS, we consider the terms where output is 0. So this is how we get SOP and SPOS form expression of a function from the truth table. There is one more fact. Sum of all min terms are 1 and product of all max terms are 0. Suppose there is a function given as f of x, y, z equals to summation of min terms of 0, 1, 2, 3, 4, 5, 6 and 7. So here 3 variables mean total 8 min terms are possible, and we are taking all the 8 min terms. So this value will be sum of all min terms, that is 1. Suppose a function is given as f of xyz as product of max terms 0, 1, 2, 3, 4, 5, 6, 7. So we are considering all the max terms here. So product of all the max terms will be 0. So in this lecture we have covered how to get expression in SOP and SPOS form for a Boolean function. Thank you.